Okay, so in this video I'm going to go through part one of the core practical. Let's have a look what we've got. So our electrolyte is copper sulfate solution. So that's copper sulfate solution. It's aqueous. Okay, so that's our electrolyte. We can see is here. There's our copper sulfate. So we're going to have copper ions. We're going to have sulfate ions, we're going to have hydrogen ions, and we're going to have hydroxyl ions. We've also got our electrodes. Now these electrodes are copper electrodes. So you've got two copper electrodes. This is what's known as an electrochemical cell. So some of you have missed this idea of an electrochemical cell. In other words, there's the cell. Okay, that's where the electricity is, and copper sulfate is the chemical. So this is an electrochemical cell. We've got the movement of electricity charge throughout this cell here. Okay, we've got a complete circuit going on. So within this circuit we've got the ammeter, which is going to measure the current in amps. We've got a variable resistor. So we can turn the dial on the variable resistor, and that will control the flow of electrons, the flow of charge, and we can see that in the ammeter. So we can set this circuit up as you did, and we can turn on the power pack. We used direct current from our power pack. And what we're able to do is change the variable resistor so the ammeter would give us various readings, and we could see those readings on the ammeter. Sometimes you have digital ammeters, sometimes you have analog ammeters. Ours were analog, so you had that little dial which moves backwards and forwards showing you the current. So what we did is we measured and wrote down the mass of these two electrodes. So we wanted to know how many grams each of those electrodes were. Then we set up the circuit, and we turned on the power and adjusted the variable resistor to give a current, first of all, of about 0.2 amps. We recorded the current, and we adjust the variable resistor to keep it constant. So when we leave this on for 20 minutes, we left it running for 20 minutes, there's every likelihood that the current will change, and when it does so, we want to keep the current at 0.2 amps. So to keep it at 0.2 amps, we change the dial on the variable resistor so that throughout the 20 minutes that the experiment runs, it remains at or as close as possible to 0.2 amps. When we did it in lesson, we didn't run the experiment for the full 20 minutes, and we didn't need to. Then, after the 20 minutes is up, 20 minutes has elapsed, 20 minutes has gone by, we turn the power off, and then we remove the electrodes. Now those electrodes had clearly changed. We removed them from the beaker, and we gently washed them first of all in distilled water, and you just dip them into the beaker, and then we rinse them, gently wash them in propanone and alcohol. Alright, so that cleaned them up. We'll talk about that more in a moment. And we allowed the propanone, the alcohol to evaporate. So a bit like aftershave of perfume. Lots of alcohol in it, and the alcohol has got a very low melting point, very low boiling point, and it evaporates off. So it dries really quickly. We measured and recorded the masses of these now dry electrodes. So we wanted to see how the mass of the electrodes had changed during that 20 minutes. And we repeated the experiment, or different groups in our class actually carried out the experiment at different currents. Okay, so make sure you understand that method. You do need to know it. So here we've got some results. You collected your own results in the GCSE exam. You're going to be given some results. So here we've got the currents. We've got 1, 2, 3, 4 different readings. So we've got a range of 4. Okay, so we've got a range of 4. We've got the mass of the anode at the start, and the mass of the anode at the end. So if we're thinking about the anode, of course the anode is the positive electrode. So what happened to that positive electrode? As you can see, that positive electrode basically lost mass. So if that was the electrode at the start, 20 minutes later that electrode is a little bit shorter. Okay, so it's lost mass. So where has that mass gone to? If we then have a look at the mass of the cathode, so we know that our cathode is the negatively charged electrode, so we've gone from 2.51 to 2.58. So we can see what's happening here is that we have that electrode gaining in mass. So this gains in mass. It's got a little bit heavier. So let's think what's going on in this experiment. During electrolysis, the copper atoms in the anode, so the copper atoms in the anode, here we go, there's the anode, they lose 2 electrons each to become copper ions. So what's happening is we're producing copper ions here. Not very easy to draw. So we're getting copper ions formed. So let's have a look here. Here's the half equation. So we start off with copper. Okay, so we've got copper in here, and that copper is losing electrons to form copper 2 plus ions. Now they obviously are dissolved into the solution, and there's a couple of electrons produced. So the electrons fly off up here around the circuit. Meanwhile, copper is coming off there, so we're getting copper ions dissolving into the solution. So that's what's happening at the positive anode. Okay, these ions dissolve in the solution and migrate to the cathode. So we know that these copper 2 plus ions are going to be attracted by the negative cathode. What happens when they get there? Well, they react when they get there. So here's another half equation showing the reaction. So when the copper 2 plus ions get to that negative cathode, they're going to gain a couple of electrons. They gain a couple of electrons. Copper 2 plus 2 electrons will make copper. So what happens here is copper is being produced. So that's why this is gaining mass, because copper ions are turned into copper atoms. Meanwhile here we're losing copper ions. So this is going to get shorter and shorter and shorter as those copper ions go into solution, dissolve into the solution, and migrate towards the cathode. Okay, so just to add a bit more detail, oxidation is loss of electrons. So that copper is losing electrons to become copper 2 plus. So what we're having here is oxidation is occurring here at the anode. At the cathode, the copper 2 plus ions arrive, they gain 2 electrons. So reduction is gain of an electrons, so that's reduction. So in this electrochemical cell, there's a redox reaction. Add these together and we have what we call a redox reaction. Okay, so reduction and oxidation. So both reduction and oxidation are happening here in this reaction vessel, in the beaker. Okay, so this is higher material stuff, being able to write these half equations and balancing them also helps. Pause the video, watch this again and again until it really sinks home. Final thing worth mentioning, and I was at pains to describe this to you a number of times in the lesson. One of the things we find at the bottom of this particular electrode, at the bottom of the anode, what we find is this sludge. Okay, so this is referred to as a sludge. So these are the impurities. So these are the impurities. I'm just going to colour that in blue, make this work. So this is the blue impurity. So where are they from? Well, this is impure copper. So there are some impurities in this copper, and they basically sink to the bottom as the copper ions dissolve into solution. So these just fall away and sink to the bottom. Alright, clearly this electrode is losing mass. Cool. So you've got 18 core practicals to learn, and this is one of them. And the questions that come up now are the questions that you could be asked. And there'll be no surprises, because those questions will be pretty much the same for each one of those separate core practicals. So if they test you on this core practical, the questions I'm giving you here are the ones that are likely to come up in the GCSE. So I've got question 2A to 2E. Pause the video, have a go at answering those questions, and then I will give you the answers. Okay, first one, state, so that means say what it is and explain. In other words, describe why. So give me a safety precaution and explain why it is a safety precaution for 1 mark. So you've actually got to do 2 things for 1 mark. They're really mean. So a good safety precaution is to wear eye protection. Okay, so basically wear some eye protection, and then you have to say why. So it prevents the copper sulfate solution, the liquid, splashing into the eyes. Okay. You could also say, as another safety precaution, you could also have said no naked flames, so no Bunsen burners when you're using the alcohol. Now, there are no Bunsen burners needed for this experiment, but just recognizing that that alcohol is flammable. Alright, so that would get you a mark. So you'd only say one of those, either no flame with propanone will get you a mark, and wear eye protection to stop the copper sulfate solution splashing into your eyes. That would get you a mark. If you simply said wear eye protection, you wouldn't get the mark. Okay, next question, state why it's important to use clean copper electrodes. So we started off with copper electrodes that were clean, so they weren't all rusty, or rather, rusty is the wrong term to use, Mr. Scott. They weren't. They didn't have a layer of oxide on them, so it wasn't sort of copper oxide. We used an emery board. We used some sandpaper to sand them down to get rid of the oxide layer. So we wanted to make sure they were nice and clean. Okay, so those copper electrodes are nice and clean, and the reason for that is so that when those copper ions reach that cathode, that the copper ions are able to get deposited onto the electrode, so they'll adhere. Okay, so you do this when you fix a bicycle tire. Okay, you file it down, and what you're actually doing is you're removing any dirt, but you're also making the surface rough. So by filing it, you make the surface rough, and that rough textured layer allows the copper to come in and basically build up on those areas. So in terms of cleaning, you're actually getting a rough layer as well. So there we go, that's that one answered. Next question, why did we use a variable resistor here? So we used a variable resistor because we are aware that the current can change during the 20 minutes of the experiment. So your ammeter reading could change as the experiment goes on, and we want to keep that variable constant. So we would change the variable resistor so we keep the current at 0.2 amps or whatever current we're trying to achieve. So there's your answer there. So D, suggest a reason why the electrodes are washed at the end of electrolysis. So we use water and propanone to wash them. So quite simply, they're washed to remove the copper sulfate. So they've been sitting in copper sulfate solution, We don't want the mass of the copper sulfate solution on the electrodes as well. That wouldn't be fair, so we want to make sure that there's no copper sulfate on them. So we rinse the copper sulfate off, then add propanone, which evaporates off quite quickly, so we'll have a dry electrode when we come to get their final mass. Okay, finally, suggest a reason why propanone is used after washing. Alright, so I made a bit of a mistake there perhaps. So we're washing with water to remove the copper sulfate, and then the propanone, we've already described the answer to that one. So the propanone, as we've already said, helps the electrodes to dry more quickly. Okay, it evaporates really quickly, as would an aftershave or a perfume, okay, which has got a lot of alcohol in it. Okay, so here's another batch of questions. You can see there's a heap of marks, GCSE marks available here. We've got a calculation to do. We've got plotting of a suitable graph to do. You then need to describe the pattern and your results. Then you need to explain the change in mass of each of the electrodes, which we've already done in this video. Explain the effect of increasing the current on these changes. So what effect does increasing current have on the mass of those electrodes? Then we want to predict the change in mass at the anode when the current is 0.35 amps. So 0.35. So we don't have 0.35 here. We do know it's in between 0.3 and 0.4. So what do you think will be happening in between these two data points? You'd use your graph, your line graph, to help you do that. Then suggest a reason, another reason, why the change in mass at the cathode is not the same as the change in mass at the anode when the same current is used. Okay, just 1 mark for that one. Describe how you could improve the experiment. Okay, so what could you do? Evaluate the experiment. What could you do to improve it to get more accurate results? So again, heap of questions there. Have a look at them. Test yourself on those. So try and write some answers, and then I'm going to show you what the correct answers are. Okay, calculating the change in mass. So that's fairly straightforward. These are the sums that you'd need to do. There's a couple of marks for that. Change in mass at the anode and at the cathode, and we can see at the anode we're losing mass, at the cathode we're gaining mass. And there's a clear pattern here. As the current increases, the loss in mass increases. As the current increases, the gain of mass increases. So there's your pattern or trend. Right, let's think about what this graph should look like. Okay, so I very quickly sketched up a graph here just to explain what's happening. So you'd label the current on the x-axis, and you can see we pick up marks that, so axes with suitable scales and labels. So that's not labelled, but you would label that as current, units being amps. And here we've got change in mass, so we've got a gain, positive numbers, we've got a loss, negative numbers, and the units here would be in grams, correctly labelled axes. So what are the trends? So a change in mass in the anode. So the anode loses mass. So what I would do there is I would plot those data points, and we'd see it losing mass. I've got a little key there, so the cathode I've got as red. And then if we have a look at what happens at the... Okay, can you spot the obvious mistake? That shouldn't say cathode, it should say the anode. Okay, so the anode loses mass as the copper dissolves, and then the cathode is gaining in mass. So here you've got a gain in mass, and you plotted a graph like that in lesson. So to answer part C, we can see as the current increases, the mass of the anode decreases and the mass of the cathode increases. That's another one done. And here I've got the answers to the last 5 questions, so I'm not going to talk my way through that. I think they're fairly straightforward from what we've already discussed.